Well, let me welcome you to the 5th Annual UCSC Grad Slam and our very first at the Kumbwa Jazz Center. This is fabulous. My name is Lori Kletzer, and I am the Vice Provost and Dean of Graduate Studies at Santa Cruz, where I'm also a professor of economics. While I have been associated with this campus for some time, this is my first Grad Slam as Grad Dean, and I couldn't be happier to welcome you all to the 2019 version of Grad Slam. Grad Slam is both a competition, first, and second, it is an awards ceremony. And in this season of awards ceremonies, it's very tempting to stand here and do some kind of silly stand-up routine. But I'm not going to do that. I'd rather get right to it and get started. Before we begin, I don't think I've ever had a chance before a crowd to say, let me take this moment to ask you to silence your devices. Please refrain from flash photography. I think you could probably read what's up there on the screen, or lighted videography. You will need your cell phones at the end, because we have a People's Choice Award that requires text message voting. But until then, I ask you to put away your electronic devices and really concentrate and enjoy these presentations without any electronic distraction. I'd like to begin tonight by acknowledging our judges. Our judges are sitting there at, I believe that's called stage right, and I want to thank them up front for their time and service. I'd like to introduce each one of them here and now. They are also described for you on page 2 of your program. What I'd like to do, judges, is I'm going to ask you, I know the quarters are a little crowded over there, but if you could stand as I introduce you and then remain standing as I introduce all of you, and then audience, if you would hold your applause until I have introduced all the judges, I'd very much appreciate it. So let me start. Justin Cummings, Program Director of the UCSC Doris Duke Conservation Scholars Program and Vice Mayor of the City of Santa Cruz. Thank you for being here. Remember, you're supposed to hold your applause. Okay. Les Gugliassi, President of the Power Association of Northern California and partner at Deepwater Desal. Bonnie Lipscomb, Director of the City of Santa Cruz's Economic Development Office. It's a test to see if you can hold your applause. Jacob Martinez, social entrepreneur and founder of Watsonville's Digital Nest. Kathleen Rose, a UCSC Foundation trustee and co-owner of the Old Adobe Orchard. Emily Sloan Pace, professor in residence at Zoho Corporation. Eric Thorne, engineer at Two Poor Guys. Susan True, Executive Officer of the Community Foundation of Santa Cruz County. Martine Watkins, Senior Community Organizer at Santa Cruz County Office of Education and Mayor of the City of Santa Cruz. And Matthew Wetstein, President of Cabrillo College. Thank you all for being our judges. Please observe in your program, we have alumni slugs amongst our judges. And as Grad Dean, I particularly would like to recognize Justin, Les, Emily, and Eric as slug graduate alums. Now it's time for applause. Thank you. I'd like to tell you a little bit about Grad Slam before we get started. Our judges will determine the champion and the runner-up by scoring presenters across 7 categories: clarity, organization, delivery, visuals, appropriateness, intellectual significance, and engagement. On a scale of 1 to 5, 5 being the maximum, you, the audience here, you will have your chance to determine the People's Choice, again, like I said, by text message voting after the last presentation. Our champion will represent UCSC at the UC System-Wide Grad Slam that is hosted by the UC Office of the President. That will happen on May 10th at the LinkedIn headquarters in San Francisco, where UC President Janet Napolitano will be the host and the MC. And I'm trying to set a very high bar for her tonight. Tonight, our finalists will tell you about the research that they are engaged in at Santa Cruz. And you will be inspired, your awareness on a variety of subjects will be raised, and you will absolutely leave here, I promise, excited about this research and really eager to learn more. Perhaps You'll be so eager to learn more that you will want to get involved and support our graduate students at Santa Cruz. And I would love to have conversations with you about that. Your program and our website, the Grad Division's website, does give a brief explanation of Grad Slam. But I'd like to say a couple of things about why have a Grad Slam. This is our 5th year, and this is a system-wide event. And it is very much sponsored by the Office of the President. And out of the recognition that in my mind, at least, the public wants and needs to know about the research happening at the University of California, and very much about the graduate students who are at the center of that research and really the center of our teaching when it comes to producing knowledge and disseminating knowledge. And Grad Slam has become one, perhaps the most fun of the many opportunities for our graduate students to communicate the research they're working on. They do it here live with you. We're also live streaming this event. And because we're live streaming it, this event will live forever on our website and our YouTube channel. Beyond kind of public access to information, this is also an opportunity for our graduate students on their professional communications development. Several of our finalists took a professional communications workshop held this fall, sponsored by the Graduate Division, and all of them prepared a video as part of the first round of participating in Grad Slam. And most of our finalists have also received kind of further preparatory training in professional communications. This is really a platform for our graduate students to share their passion about their research, but it also launches them forward as they think about the roles they will play and how they want to best communicate the research that inspires them. With that, we are about to begin. I have one more instruction, if you'll allow me to call it that. After each presentation, I will share the stage with a presenter, and we will be in conversation. This conversation is not a formal part of their presentation, but this interlude between presentations gives our judges time to score each presentation. So I hope you are entertained by the conversations we have. Please know that we are buying time for the judges and that it is not a formal part of their presentation because it might be informal and it's likely to be a little impertinent at times. But it's all part of the evening. So with that, I would like you to join me in a round of advance applause for our finalists, and then we will begin. So please, a round of applause. Thank you. So we have 13 presentations, and our first presenter is Caitlin Krager. Caitlin is a 6th-year PhD student in ocean sciences. She studies seabirds and the effect of climate change and other environmental stressors on them. Please welcome Caitlin to tell us about the resiliency of seabirds in a rapidly changing world.
Imagine you're a seabird, and your home is on an island surrounded by ocean. Now imagine you've just hatched a chick, and it's hungry. If you're like this albatross, you have to fly hundreds of miles a day over a vast ocean to find fish to bring home to your chick. And then you've got to do it over and over again. Luckily, albatrosses are super energy efficient flyers. They're built like gliders with 6 to 11 foot wingspans, and they can lock their wings into place to soar on the wind. But searching for food can still be stressful and costly, especially when encountering unexpected changes. Over the Southern Ocean that wraps around Antarctica, where most species of albatross and many other seabirds breed and forage, wind speeds over the next century are forecasted to lighten towards the equator and intensify towards the South Pole as a result of climate change. And it's unclear how this will impact seabirds. Light winds can make it harder to soar without stalling and harder to gain lift after catching prey. These birds don't have engines, so they've got to run on the water, flapping these awkward long wings to get back up into the air. At the other extreme, strong winds can cause turbulence or push birds off flight paths. To understand how different albatross species might cope with these changes, I spy on them. Using GPS tracking devices, I record where they go over the ocean. Then I extract satellite-derived wind data along their flight paths to see how they respond to various wind speeds. I also collect a blood sample so I can measure their stress hormone levels and their metabolic rates to calculate how hard they work at sea. I've found that adults with chicks have a heightened sensitivity to stressors, and measuring their hormones right after foraging can signal environmental disturbances. I've also found that albatrosses expend more energy in light winds and during takeoffs from the water, but strong winds are less costly. My next step is to use this information to model how different climate change scenarios will alter the energy budgets and trajectories of different species. Albatrosses foraging towards the South Pole might actually benefit from intensifying winds because gaining lift with a heavy food load will be easier. And these dynamics are important because albatrosses live and breed well into their 60s, raising at most 1 chick a year. So adaptation is not happening fast, and their resiliency to change within their lifetime is crucial. And predicting what species may be harmed versus helped by climate change gives us a head start in prioritizing conservation efforts. Thank you.
Caitlin, thank you.
Thanks.
Thank you. Okay, I did try to listen behind that dark curtain, so if you don't mind, I'd like to ask you a couple of follow-up questions.
Please do.
So first of all, kind of how and when did you begin studying seabirds, and whether there's some moment?
Oh gosh, I started studying seabirds, I think in 2009. I went out to Southeast Farallon Island off the coast of San Francisco as an intern for what is now called Point Blue Science. It used to be PRBO, a bird observatory, and I worked with a bunch of different seabirds, and I fell in love with them. Yeah.
Okay, that's the moment. So can you tell us a little bit about how it is you work in the field? Like how long you go out and where you go and time of day? And
Well, where I did this research was Campbell Island, which is in the subantarctic. So we took a sailboat, took 3 days to get there. It was really rough. It was in the Southern Ocean. And then we bring all the food we need for 4 months. There were only 2 of us at the Albatross colony, 2 of us at the penguin colony. Wow. And we didn't have electricity. We brought our own car battery and some solar panels, and there's not a lot of sunlight out there.
no.
But we had a centrifuge to spin blood down. We had to program our GPS tags with the computer, so we were.
Wow.
It was tough. Yeah. I won't tell you how we paced ourselves.
Yeah. Just you and one other person, and then all the seabirds.
And all the seabirds. I learned how to do an albatross mating dance really well, but I'm not going to imitate that for you guys.
So, well, I know that, and I was about to say, so I understand you know how to do an albatross mating dance. So, care
do
to
you
share?
want the? So there's the Hawaiian albatrosses that have a much better one.
Yes,
And then
that
there's
one.
the ones I studied, which is kind of theirs is a little
I'm
more
going to
annoying.
let you choose.
Okay, well,
Okay.
they first they do this. So if I were dancing with you, I would do this, and you would dance with me, and then we might shake our heads like this. You gotta make that sound.
You do that.
And then there's like a, and then there's a. They look under their wing, and then the finale is a sky moo. Wah, and that's what we do.
Well done. Well done. Thank you. Is that enough time? Okay. Thank
All right,
you.
thank you.
Thank you. Wow. She is brave. Okay. If the judges are ready, our second presenter is Allison Wynn, a second-year PhD candidate in psychology. Allison's research explores fake news and desirable difficulties. Welcome, Allison.
Today, I'll be talking to you about fake news. So fake news has been a problem in this country since our very first presidential election. In the election of 1800, Thomas Jefferson and John Adams published a series of increasingly inflammatory and escalatory articles about each other. And now, in our current political climate, it seems clear that we need to develop some sort of prevention technique for fake news. But in order to have prevention, we need understanding. What is fake news? Well, when I talk about fake news, I'm talking about a story that has been written in the style of news in order to imitate it, to be some sort of satirical post or a prank or a hoax. And something about these stories is really compelling. It's really believable. And these stories are believable for a variety of reasons. There's a really strong emotional component. People feel really pulled in by emotion. There's a really personal component. Something about that feels really true or really relevant to certain people. Or there's some sort of moral story or moral judgment in these stories. And all of these mean that fake news has a strong emotional pull to it. And in order to stop people from falling for fake news, we need to find a way to divorce that emotional reaction from a logical reaction. And one way you can think about doing this is by introducing something that makes fonts harder to read or makes text harder to read. So imagine spilling coffee on your newspaper. It's really difficult to make out the letters, right? Yeah. So if you can do this, research has shown that people with harder to read materials actually have to think harder about what they're reading. They have to be a little more skeptical, they have to be a little more critical, which is awesome, right? So we hypothesized that we could apply this to fake news by making harder to read materials, and that would make people think harder about what they're reading and be more skeptical about fake news stories. And that's exactly what we did. We took 8 articles of varying truthfulness from Snopes.com, which is a debunking site, and we put them in an easy-to-read font and a hard-to-read font. So we chose an easy-to-read font, Times New Roman, and a hard-to-read font, Hattenschweiler, and you can tell our hard-to-read font is very difficult. It's not easy at all. And once participants read this, we asked them to make a judgment of truth. So we asked them, how true does this feel to you? Not an objective judgment, but a subjective judgment. How true does this feel? And what we found was that in the hard-to-read font, people rated all items as less likely to be true. This means that they were more skeptical about what they were reading. This is awesome, right? It means our manipulation worked, which is really cool. But another thing, it means that we can use this information to develop some sort of tool or technique to prevent people from fake news. Imagine an app or a browser extension that when you're reading a news article, you can click on it and it'll make it harder to read. You're going to think more critically and more deeply about these things. Having this sort of tool or browser app or extension would be awesome and will lead to better outcomes for our democracy. Thank you.
Thank you. Thank you. So I'm curious, what drew you to study fake news? Was there a particular moment or a particular story, or could you share with us that moment?
I'm kind of into history, and the story of Thomas Jefferson and John Adams just engaging in this flame war in the 1800s is just hilarious to me. I think that's really funny, and the fact that we can still see this today I think is really compelling. So I think since it's always been an issue, I think we really need to understand the psychology behind why it's an issue.
That makes sense. That makes sense to me. So this difficult to read font for increasing skepticism, can you imagine testing it much more broadly? Can you tell us a little bit more about kind of, not quite future steps, but I'm really curious about how you think about testing that further.
So we actually looked at trying different kinds of fonts. So is it just a hard-to-read font because it's bold? Is that what's driving the effect? Is it font authority? Do people just naturally give Times New Roman more authority than they do other fonts because that's something everything is posted in? And that's something we're actually working on now, is just checking font authority to make sure that's not what's driving the effect.
I never actually thought of the phrase font authority, but it makes perfect sense, right? It makes perfect sense in this framework. Do you see this as a strategy that could be more broadly implemented?
Definitely.
Internet, yeah.
I think it would be awesome if Facebook had a thing where you read something on your timeline and you could click maybe I'm not sure about this, and then it makes it hard to read, and then you can just be wow, maybe I wasn't sure.
That would be way cool.
That would be awesome.
So to those of you who've read the entire program, which probably not you, but you know this, you're one of 3 finalists who are bread bakers.
This is true.
Do you have a particular bread that is your favorite to make?
Yeah, so I'm really into sourdough. I actually developed a sourdough English muffin recipe, and yeah, and I wrote it up, and like it's on my like recipe blog, and I'm super into like sourdough, so that was really fun.
That's great.
Yeah.
All right. Thank you very much.
Thank you.
Thank you all. Our third presenter is Regina Spranger. She's a third-year PhD student in ecology and evolutionary biology. She studies West Coast amphibians, especially salamanders. Her talk is titled Extinction Risk, Surviving and Thriving. Please welcome Regina. There you go.
So climate change. We've all heard about it. We're worried about melting glaciers, rising seas, and how animals will survive. We know, on average, that global temperatures are going to increase. However, climate change might not alter habitats to be outside of the survivable range of animals, but it will alter habitats outside of the optimal range of animals. This means that climate change might not directly cause extinction through overheating, but instead, a population's reproductive success or survival might decrease because they aren't living optimally till the population whittles away. The way I like to think about this is imagine a population of salamanders that can physically survive an increase in temperature. However, this rising temperature raises their metabolism, and now they need more food and they can't get enough food. And eventually the population will shrink and possibly go extinct. So I think about this as the idea of surviving versus thriving. Most animals will be able to directly survive an increase in temperature. However, this change of climate might force these animals to change their behavior, and they'll no longer be able to live optimally or survive. So the way I study this is I research how animals will be able to adapt or acclimate to increasing temperatures. I study this by seeing if animals living in different temperatures can change their behaviors. So the specific group of animals that I work with are salamanders. So this genus in my fieldwork ranges throughout California and into New Mexico and down into Mexico. It includes organisms such as our local long-toed salamander, our barred tiger salamanders, axolotls. And the way I study salamander acclimation is by raising larvae, which are baby salamanders, in different temperatures and seeing if they can change behavior. So I'm raising these larvae in increasing temperatures to see if their traits will increase as temperature increases. And if they can do this, then we are saying they are acclimating. They're physically able to change something about their bodies that allows them to handle these stresses. So if salamanders can acclimate, and we are seeing the first signs that they can, then they'll actually be able to survive climate change better than we've previously thought. Since my work spans across North America and includes all throughout our region, I'll be able to use this information to model extinction risk across all of amphibians, and then use this to help with their conservation. Because it's important for salamanders and all animals to not only survive climate change, but to thrive.
Thank you. So I have a complicated question for you.
Okay.
Why amphibians?
Why? Oh, amphibians are really important for climate change. Because they have life stages both in the water and on land, they're going to be affected by climate change in very many different ways. So they'll be affected in their aquatic environments, in their terrestrial environments, and they tend to be some of the first organisms that suffer from different effects in their environment, like climate change. So they are one of the first signs that climate is going wrong for them.
Okay.
Yeah.
Got it. So I'm not actually sure I ever thought I would stand here with a microphone and say that amphibians are all adorably cute. Yours seem to be.
Oh, they are.
Do you have a favorite?
Ooh, I think the barred tiger salamander larva, the guy at the bottom with his big kind of spanned out gills, might be one of my favorite.
Okay,
Yeah.
I can see that. I can see that. So does your research give you hope in this complicated conversation and understanding of climate change?
It does. Obviously, there are some moments that are not so great, but I get to work with a lot of different people that are working very hard to help these animals survive and conserve. So one of my favorite parts about my research is I get to do the broad scale. But I also get to work with local conservation groups in all the places, including here, and actually make plans to directly use my research to help the amphibians. Yeah.
Okay, so I have one more personal question. I see you
Okay.
work in the animal shelter.
I do.
Do you have a rescue pet? I do.
Oh, well, I do, but he's not from the shelter. I have a rescue pet, but his name is Groot, and he's a gecko. So,
Wow, that is way cool.
Yes.
That's way cool. Okay, thank you very much. Our fourth presenter is Benjamin Lehman. He's a third-year PhD candidate in physics. Ben takes us out of this world and into space with his talk, Listening to Dark Matter. Welcome, Ben.
Can everybody hear me okay? Great, that means you're part of the observable universe. Our universe is full of stuff, billions of stars in billions of galaxies, but something's wrong. We've learned that what we see isn't all that's out there. Let's take on a rocket ship and go around a tour of the Milky Way. Because everything has a gravitational pull, we can measure exactly how much stuff there is here. But if we add up everything we can see, it only comes to about 20% of what we know is there. The rest is something invisible. It's not like any kind of matter we've ever seen in a lab. We don't know what it is, so we call it dark matter. Now, as a physicist, this is very embarrassing for me. We've spent the last century and millions of dollars so that we could tell you what the universe is made of, and we just got 20% on our final exam. So what is dark matter? We know it's out there. It tugs on stars, it holds galaxies together. As far as we can tell, this room is full of it. But in order to test our theories about what this stuff is, we need some way of interacting with it. We can't see it, we can't bump into it, we only know it's there because of its gravitational pull. That's why most research into dark matter has focused on finding some new force or interaction that we can use to play with it. And so far, we haven't found anything. But I got another idea. Maybe we can learn about dark matter by using gravity where it's strongest. And if you're looking for strong gravity, there's nowhere better than around a black hole. So let's get back in our rocket ship and visit NGC 7674. This is one of our laboratories in the sky. This is a pair of supermassive black holes. Each one is millions of times more massive than the sun, and they're about to smash into each other. These black holes are so massive, with such powerful gravity, that they suck up some of the dark matter around them. So I asked, what can we learn about dark matter from the way these black holes eat it? What I've discovered is that the properties of dark matter can have a huge effect on the behavior of this system. If dark matter particles bump into each other, even a little bit, then these black holes can swallow them much faster. And that changes the choreography of the black holes in a way that we can measure. This could be one of the most sensitive ways yet for us to measure the forces that dark matter experiences. And the best part is, we don't have to catch any dark matter in the lab for this to work. Instead, we can listen to the effects of dark matter using gravitational waves. Let's take our rocket back to Earth. A new satellite called LISA is going to be able to listen to gravitational waves at this frequency for the first time. When we compare my models to the data, we'll be able to tell if dark matter particles bump into each other or not. That's going to give us new information that's going to provide us with a critical clue about the nature of dark matter. It's going to allow us to test our existing theories and come up with better ones. It could be the clue that tells us what the universe is made of.
Thank you, Ben. So I'd like to ask the motivational question. What brought you to the study of dark matter? Why dark matter?
Look, as a physicist, again, I want to know what the universe is made of. I want to study the physics of the particles that we are, that everything else around us is. And to find out that everything that we know about is only 20% of what's out there, that's a huge opportunity. That's a huge unknown. And a question like that, I can't get away from.
That's a good answer.
Thank you.
That's a good answer. So, in your spare time, do you do a lot of night sky observing? Just go outside?
I wish, but these days, all the observations that we use are done by very, very fancy equipment. It's all done by computers. Some of my friends in the observer community, they get to go and visit these telescopes on mountaintops in South America, and they get to go down to Antarctica and plan observations. But as a theorist, I basically get to stay in my office on the UCSC campus.
I'm sorry.
It's okay. It's a nice campus.
I'm sorry. I've heard. So that means you don't actually get to travel anywhere, right, for your research. I mean, you have to stretch out the story in order to travel for your research?
No, the part of being a theorist is coming up with good ideas and sharing those ideas with people. And the field advances a lot faster when we get together in the same room. So theorists are always moving around from country to country just to mix those ideas up, have workshops together, see what comes out of them, and that's what moves the field forward.
That is the most exciting description of theory and theorists that I've heard. So thank you. No, thank you. I'm an empirical person. What can I say? So you are the second finalist who likes to bake bread. So what's the favorite bread?
For me, well, I'm Jewish, and there's a Jewish bread called challah, which is traditionally eaten on Fridays and Saturdays, and I would be eating it right now if I weren't here with all of you guys. But I actually learned to bake because my favorite bakery where I got challah from every week, they went out of business. And you grow up with that taste. It's the taste of home, and I figured I can't switch to another brand. I have too much loyalty, so I better start making it myself.
That's fantastic. I would love to have a slice sometime. On a Friday night, perhaps.
On a Friday night.
All right, thank you. Thank you. Min Mei Wong is in her second year of PhD study in computer science and engineering. The future is the Internet of Things, or capital I, little o, T, capital T, and Min Mei is working to get us there. Let's learn from her talk, Efficient and Secure Communication for the Internet of Things. Welcome.
We use the internet. The internet makes our communication easier. We, the academia and industry, are together building the Internet of Things, or IoT, to connect the objects around us. The IoT makes our lives more convenient. When you finish your day of work and leave your office, you can simply use your smartphone to tell the home thermostat to lower your home temperature. You don't have to wait for your house to cool down until arriving home. My thesis focuses on the study of providing secure communication for the IoT. I pay attention to two important types of security. First, confidentiality, which means the communication is protected from being accessed by others. For example, the data from your healthcare devices transmitting to your medical advisor cannot be exposed. Second, integrity, which means the communication data must be complete and cannot be modified. For example, your personal heart rate data should not be modified. Otherwise, it will mislead your medical advisor. Scientists have already developed secure communication protocols for the internet. The authentication is the primary step, which relies on encryption and decryption methods. Why do we need to study the problems for IoT? The key problem is that IoT devices are small, cheap, and low power. They have limited computation resource, but the authentication step is computation intensive. The devices may take a long time to finish or run out of battery. So we need a secure and efficient communication. What's my unique idea? The magic of my research is just one word: collaboration. Devices in a local network can cooperate with each other. Two devices, A and B, both want to communicate with a remote server C, and A has already authenticated C. An efficient way for B is to ask A for help. A can reuse the authentication result and directly send to B.
This collaboration mechanism benefits both of them in saving resources. However, deploying this system into IoT environment poses many challenges. We need to find the collaborative devices, and we need to distinguish the authentication result from a malicious one. In my research, I designed an efficient data structure to locate the collaborative devices, and I applied the trust model to choose good IoT devices to be collaborators. My goal is to provide secure and efficient communication, contributing a convenient, smart environment for all of you. Thank you.
So there's a certain pattern in my questions, and I'll
Yeah.
start in the same place. How did you get interested in the Internet of Things?
Well, I appreciate the technology that is used in our daily life, like a smartphone, smart camera, smart air conditioner. At first, we need to provide the security by using this technology. But another point is we need the technology is fast. So I get involved in this topic to provide an efficient communication in the Internet of Things. Okay.
Got it. So I want to speculate a little bit about the future. How many years away are we from being able to walk into a Internet of Things household, a bunch of internet connected appliances, and I can just do it all from my phone, or what? Is this science fiction out there, or is it closer to us?
I think it's closer to us because I think the technology evolves very fast. In the near future, maybe the technology will all applied in our daily life. That's my dream, and that's my goal. I hope my research will make some contribution to the apply of this technology in our daily life.
Very good.
Yeah.
So I know from having read the program that you like to run, and you
Yeah.
run on campus.
Yeah.
So do you take big loops around campus, small loops around campus? What would you call yourself?
I think this
There's
is
a lot of hills
big loop.
there.
It takes about 7 kilometers.
Okay.
I
That's
think it's a
decent.
relatively big loop around the campus.
I think so.
Yeah.
All right. Thank you very much.
Thank you. Thank you.
Our next presenter, Theodora Block, is a fifth-year PhD student in ecology and evolutionary biology. Theodora studies a local part-time feathered resident, the golden crowned sparrow. Let's learn how they organize socially from her talk, Understanding Social Networks in a Little Brown Bird.
Imagine if birds had Facebook. Ding! Judy, the sparrow, just got a friend request from Tim, another sparrow. Judy is friends with Sarah, Craig, and Mary, and now Tim can join the flock. What might be a casual interaction for humans is much more serious in birds. In this case, it can mean the difference between life and death. For small birds, surviving winter is hard. Between finding enough food and avoiding being food themselves, how do they do it? One way is by making friends. I mean flocks. By forming flocks, small birds get benefits of being in a group, more individuals to look for food and watch out for predators. I study golden-crowned sparrows and how different behaviors can help them survive. Golden-crowned sparrows are a small brown bird with a beautiful black and gold crown. They breed in Alaska, then migrate to California where they spend their winters and where we study them. My research group discovered that golden crowns don't just randomly hop around looking for food, but actually form complex social groups, similar to primates. We use social network analysis techniques, a bit like Facebook, to understand how individual birds are connected with each other. We found golden crowns form distinct communities of about 20 to 30 birds. They spend most of their time only associating with birds in their same community. They migrate back to the same tiny patch of trees every winter and spend time with the same birds. In other words, they come back and hang with their friends year after year. So we have these birds in social groups. Within them, birds have different social statuses. Some of the ways I measure social status are how many friends a bird has, how much they associate, and if there's much variation within that. I want to understand, why do birds have different social statuses? Does it depend on their physical appearance, body size, sex, or other behaviors? I've found a bird's social status doesn't depend on just one thing, but is predicted by a blend of how dominant it is and its sex. Females and more dominant birds actually have more friends and are more strongly associated with those friends. So this means dominant birds might actually have to socialize differently to maintain their dominant status, and this can have important implications for how they survive winter. My research helps us understand not only how animal groups are organized, but why. So don't forget to send your dominant female friends a friend request. And maybe you can join the flock too.
So, Theodora, I understand that you learned to sing the Golden Crown Sparrow song at the age of 8. I'm not going to ask you to sing it, although you could do that. But I want to know, was that an early indicator to you or to others that this might be your thing in life and that you would study them in graduate school?
I wish I could say yes to that, but I actually had no idea that that was that species. I knew it was a bird and that it could sing. But it happens to be a really simple song, so it's a really memorable one. So if you guys learn it, you can hear it everywhere in Santa Cruz, and suddenly you're like, oh, there's that bird.
Okay, so Caitlin did the Albatross courtship dance, so I think I have to ask you to sing the song.
Well, it's more of a whistle, so you might want to turn this down a little. It sounds a bit like just 3 notes.
Okay.
So can I hear it back? It's pretty good.
Okay, so I have one last question. That's very good. I don't whistle very well, so I'm not going to do that. So you likened sparrow social networking to online social networking. Does the similarity extend to like bad social networking that humans can engage in bad social networking? Do sparrows engage in bad social networking?
Well, they don't really go for the subtle disses so much as physical fights.
That strikes me as bad social networking.
Yeah. So within their social network, they actually have this complex dominance hierarchy as well. So you'll have the birds with really strong, bold, and crowns that have a lot of black, a lot of gold colors. Those birds are actually more dominant, and they're higher up in the pecking order.
Okay.
So,
Very good.
yeah.
Thank you. Our next presenter is Natalia Kulinka. She is in her 6th year in the History of Consciousness PhD program. She is a native of Minsk, Belarus, and she studies the collapse of the former Soviet Union and the social changes leading up to and following that event. Her talk is entitled Social Change and Democratic Participation in the Former Soviet Union and Beyond. Please welcome Natalia.
In 1991, the Soviet Union experienced the shock of a second wave of miners' strikes. The first was in 1989. During a rally, one of the strikers called for the eradication of historical injustices, demanding to give workers back their plants, factories, mines, and land. This never happened. Instead, the Soviet Union collapsed in December of the same year, leaving many former Soviet citizens puzzled by a question. How did we end up with capitalism and socioeconomic inequality when what we wanted was freedom and democracy? To answer this question, I consider the broader framework of social change and democratic participation in a series of case studies. In my analysis, I assume that development is not a movement without choice, but rather a chain of bifurcations. This understanding emphasizes the importance of participation in decision-making. The miners' strikes in the Soviet Union present a case in point. It's widely believed that the strikes of 1991 contributed to the Soviet Union collapse. However, some years later, many of those involved ardently denied that that had been their goal. You may wonder what happened. The strikers did indeed demand a multi-party democratic political system. But simultaneously, they insisted on widening the spectrum of social benefits, including a paid 3-year maternity leave for women. In other words, the democracy they envisioned as an alternative to the one-party rule wasn't liberal democracy on the Western model, it was rather socialist democracy with its stress on economic redistribution and a broader social safety net. That such reinterpretation of the idea of democracy is not unique to former Soviet citizens is demonstrated by recent research conducted in 4 countries: Kenya, Serbia, Egypt, and South Africa, under the leadership of political communication and democracy scholar Catherine Woltmer from the University of Leeds. Interviews with political activists and journalists in South Africa, for example, highlight local people's efforts to reinterpret the idea of democracy to emphasize the need for more egalitarian relationships among individuals. Assigning different meanings to the concept of democracy can be a powerful tool that prevents some views from being incorporated into developmental policies, as the case of Soviet miners illustrates. Ultimately, I argue that people's contribution of their views and ideas to decisions regarding social and economic development in their countries is what democratization and development should be about.
So you grew up in, and just told us about, the kind of immediate period of time after the breakup of the Soviet Union. So was the Soviet Union and its history, this is a more serious question than maybe I have asked other people, was it a large part, as you were growing up, of your academic study? Or, is this...
I was born in the Soviet Union.
I know.
And when I was old enough to remember perestroika and people's hope for good changes in their life and their enthusiasm for these changes. And then I remember their bitter disappointment with the results. So when I, with my family, moved to the United States, and I was admitted by this wonderful History of Consciousness program, there was actually no choice for me. I decided that I want to understand why it happened and why it happened in this way.
Yeah. Thank you. Thank you for that. Any reason for optimism?
I think this is a question for different circumstances. I mean, don't spoil this wonderful celebration.
Correct. Fair enough. Fair enough. That was exactly the answer that question may have deserved at this particular moment. Let me ask you last, perhaps a more personal question that I know that of your joy of reading and your book collection.
Yes.
What are you reading now, and what would you recommend?
I am reading now a wonderful book written by American researcher Ellen Maxis Wood, Democracy Against Capitalism. The book was published in 1995, and I highly recommend it. So
Thank
please
you.
read it.
Thank you very much. Thank you. Our next presenter is Anna Lowe. She is a 6th-year PhD student in ocean sciences. She studies local fish, particularly rockfish, and will tell us about their infant wanderings in baby fish. Where do they come from? Where do they go? Please welcome Anna Lowe.
The lives of many marine species include 2 phases. First, a larval stage, when the babies are extremely tiny, many are unable to swim, and therefore they're being moved around by the ocean circulation. Second, the adult phase we are all familiar with. Marine species with this two-phase lifestyle range from sedentary animals like barnacles and corals to mobile ones like crabs and fish. During this larval stage, a few of the offspring will return to their natal populations. Some are moved short or great distances along the coast to settle in other populations, and most, over 90%, are lost, either eaten or moved away from suitable habitat, unable to survive. This larval stage is when many marine species are the most vulnerable. By advancing our understanding of this phase, we can design more effective conservation solutions. To this goal, I am part of an interdisciplinary team investigating larval transport. We focus on the kelp rockfish populations in southern Monterey Bay and Carmel Bay, where there are several marine protected areas. I have built a high-resolution model that simulates the ocean circulation and how it moves larvae from these two populations. The beauty of this case study is that our findings are applicable to many other marine species. So what did we find? We found that the larvae that settled around the Monterey Peninsula were transported locally, almost exclusively within Monterey Bay or Carmel Bay, meaning that those larvae didn't get swept offshore or down the coast by strong currents. Instead, those larvae were retained within the region by local features in the circulation. So let's dig into the circulation. Off the California coast, nearshore water is very cold, whereas the offshore water is typically 1 or 2 degrees warmer. When there's a large difference in temperature between these two water masses, the interface between them is called a temperature front. In our study region, temperature fronts frequently developed off the southern edge of the Monterey Peninsula, and they act as a transient barrier, or a gate, to the exchange of individuals between these two populations. So this research demonstrated that the nearshore circulation plays a crucial role in determining which larvae will survive and where they will settle. So when you're thinking about conservation on the scale of a marine protected area or a kelp forest or a coral reef, you need to consider the local circulation, not just the larger scale patterns. So far, marine conservation has focused almost exclusively on the biology. The next step is to incorporate the physical circulation into that discussion. We all want vibrant and healthy coastal ecosystems, and the physical circulation enables these systems to thrive. So the next time you're diving in a kelp forest, or you're going fishing, or gawking at marine life, I hope you think, where did the adults come from, and where will their offspring go? Thank you.
Thank you. So tell me, how did somebody from landlocked Colorado end up in ocean sciences?
Well, luckily we have Monterey Bay, right?
We do.
My first plane flight, actually, when I was about 3 months old, was to come out here to this area, and somehow my mom knew about the elephant seals at Año Nuevo, and so my dad carried me in the backpack thing when I was 3 months old, and ever since then, every 2 or 3 years, we would come out and visit here in the aquarium to see the elephant seals, and so it's really been Monterey Bay, so I kind of came full circle coming back here to grad school. But it's always been a special place in my heart.
Well, and it's a very special place. So I actually have a specific question from your research. Do you have any estimate of the percentage of fish larvae that make it to adulthood?
So the 90%, most of those are going to die. So about 10% are the ones that make it to that juvenile stage when they're about this big. And then a lot of those still get eaten. And so I think it's closer to 5 or 3% that will actually make it to the mature stage that are about this big. Now, don't be too alarmed because they do release 100,000. So they know that most of them are not going to survive, but the numbers are very, very small that actually reach adulthood.
Wow. Okay, the last one is a personal question. So I understand you played Division I soccer.
I did. Very proud of that, yeah.
Do you still play soccer?
I do. I actually play in the Santa Cruz Adult League, and we were champions last in the fall. So,
hey, very good.
Thank you.
All right. Well, thank you very much.
Thank you.
Okay. Our next presenter is Sarah Keenley. Sarah is a 6th-year PhD student in ecology and evolutionary biology. She studies seals, including the largest of them all, elephant seals. Her talk is titled High Risk, high reward, sex-specific foraging strategies of seals. Please welcome Sarah Keenley.
What if I told you that males and females are different? Now, I'm obviously not the first person to make this not so startling observation. Charles Darwin himself wrote about differences between the sexes, and you and I could go to our local bookshop or Amazon and buy a copy of Men Are From Mars, Women Are From Venus to realize that this is not an isolated phenomenon. In biology, when we talk about differences between the sexes, especially in terms of size or shape, we call this sexual dimorphism. And it can take a myriad of forms, from the quintessential mane of a male lion, to differences in body size in gorillas, to the ornate and showy tail of a male peacock. And this begs the question, why are males and females of the same species different? So to answer this, for my PhD research, I work with one of the most sexually dimorphic species on the planet, the northern elephant seal. Males and females show extreme differences in size, with males weighing up to 5,000 pounds, making females look dainty in comparison at only 1,000 to 2,000 pounds. And in addition to these differences in size, they also show differences in shape, with males having the very long nose that gives the species its name. And I was interested in how these differences in size and shape translate to differences in other aspects of their biology. And I specifically study feeding because it's a rather important process if you like living. I found that males and females use completely different feeding strategies when they're at sea. Males are continental shelf predators that feed at the bottom of the seafloor, whereas females travel throughout wide swaths of the North Pacific Ocean, feeding in the middle of the water column. And these differences in location and dive behavior translate to differences in foraging success. Males are much more successful than females on these trips, putting on nearly 5 times as much mass as females. But this comes at a cost. Males also have a much higher mortality rate compared to females, with about 90% of females surviving these at-sea trips compared to only 56% of males. So there's this trade-off in foraging success and survival, and this seems to be related to their life history. If you're a male, you need to get big quick so that you're competitive in male-male combat for access to females. And if you're lucky, you get to do that for 1 to 2 years, and then you die. Yes, but if you're a female, there's a lot less pressure to get big. Instead, you want to have a pup every year and live for a really long time. So males are adopting a high-risk, high-reward strategy, whereas females are adopting a lower-risk, lower-reward strategy. So together, my results have important implications when we think about the conservation and management of sexually dimorphic species. Because in northern elephant seals, what I've shown is that males and females aren't just different, they're essentially different species. Thank you. Oh, I'm on this side.
Thank you. Thank you. That was fascinating. So I have a question somewhat like the one I asked before, and
I'm
that is,
shocked.
how does the person, I know, because there's a really discernible pattern.
Right, yes.
Right, people who study behavior.
I'm a scientist, so
I know.
Yeah.
Yeah, I think I qualify as a creature of habit. So how does somebody from, Austin, Texas,
Yeah.
end up studying elephant seals on the West Coast?
Ben Affleck. Very young Ben Affleck was in a documentary that was geared towards school children, and we saw it in school, called Voyage of the Mimi. And he and his team of buddies are going out and studying humpback whales. And I'm pretty sure that's where I learned the word marine biologist. To be fair, I thought I'd be playing with dolphins and picking up seashells, which I don't do. And in that, I think that must have been where I kind of really was inspired that this was a career that you could do. And then that was it. It was that or astronaut, and marine biologist actually was the more reasonable job choice for me. Yeah.
Okay.
Yeah.
All right. So I raised 2 kids here, and you know the story you tell. I mean, that's not a story. The stern warning you give your kids before you see elephant seals, right, is don't do anything stupid and don't get too close.
And don't become an elephant seal in another life.
Well, that's what I heard as I stood back there behind them.
Right. It would be terrible.
It would be
All
terrible.
life cycle.
But so, what kind of precautions do you take, if any?
Yeah, a lot of training. I do not recommend children or really anybody doing what we do. And I work with a really highly trained team of people, but we're walking up right next to the elephant seals to do all
The
of the work
things
that
we
do
tell
with them.
people not to do?
Yeah, that's what we're doing. But we're very trained and we have all of the permits. But
We're not always highly qualified, yes. I'm a sixth-year PhD student. I've been doing it for a while now, yeah.
Okay. So I understand that there's a trip to Antarctica in your future.
That was not in my bio, but yes.
Okay.
Yeah.
Can you just a little bit about that? What
Yeah.
will be
So I'm gonna-
not elephant seals?
Not elephant seals, although there are elephant seals down there. There are southern elephant seals, completely different species. They're separated by, two different hemispheres. I'm working with leopard seals, so Happy Feet, the terrifying seal in it with like the crazy teeth. We're working with that species to study their feeding behavior and physiology. And again, we're doing things where we're right up close to them, and their teeth are very scary, and their eyes are red rimmed, and they have blood-stained mouths. It's amazing.
Okay. Well, thank you, and better you than me.
Thank you.
Wow. Okay. Our next presenter is Priscilla Sung. She is a seventh-year PhD student in psychology. Her research explores mental task switching and how bilingualism affects it. Her talk is entitled The Hidden Workout of Bilingualism, Lessons from Preschoolers. Please welcome Priscilla Sung.
Have you ever found yourself in the middle of writing a work email when your friend sends you some hilarious video or photo? Now, wouldn't it be bad if every time that happened, you would accidentally write LOL and a bunch of emojis in the middle of your work email? You ever wonder what stops you from doing that? Well, it turns out it's this special mental ability called task switching, but it goes way beyond emailing and texting. Actually, it turns out we use it all the time in our daily lives. In fact, you could even say that our success at our jobs, at school, at home, depends on this ability to kind of switch between the different roles that we play and the different expectations that we navigate. But what does this have to do with being bilingual? So some experts say that switching back and forth between languages uses the same kind of muscle that you use when you're, say, switching between emailing and texting. In other words, by code switching, or switching between your languages, bilingual people are exercising this task switching muscle a lot more often than people who speak one language. So it's this hidden workout of bilingualism that fascinates me. Because it turns out it's not just about how many languages you speak, it's about how you actually use them in your daily life. So take my nephew Aiden, for example. In one version of his life, he speaks only Chinese at home, only English at school. He probably wouldn't do too much code switching. It's more like he kind of lives half his life in one language and half of it in the other. Version 2. Say that everyone at home and school speaks both languages. He'd probably do a lot of code switching, maybe even speak some Chinglish. But no matter what language he speaks, everyone would understand him. Version 3. Say that just his dad speaks Chinese and just his mom speaks English. And maybe he goes to a bilingual school, but some of the teachers speak only Chinese and some of them speak only English. Now, he'd have to be really, really careful to pick the right language to speak to the right person. So I believe that it's this third version, the one where you have to carefully and constantly code switch, that kind of gives your brain the tougher workout and makes you a better task switcher. So my research looks at exactly that question, but in a particularly adorable group of bilingual people, 3- and 4-year-olds at a bilingual preschool in San Francisco. And how do I measure task switching in these tiny human beings? Well, first, I give them some objects. I have them sort them based on one rule, like by shape. And then I switch the rule on them and have them sort the same objects based on this new rule, like by color. To you, this might sound simple, but for little kids, it's actually pretty tough, like hilariously tough. So what's the takeaway here? Because it's a long road between sorting by shape and color and not writing LOL in those work emails. So research has shown that there are actually many ways to get there, but I have a hunch that code switching is one of them. And as a developmental psychologist, my focus is on the process, on how all this change happens over the course of our lives. So I study how speaking multiple languages shapes the development of our brains, because what we do as kids lays the path for how we learn to navigate our complex roles as adults. Thank you.
Thank you. So tell me how you arrived at this topic. And is it related to your own past? Is it related
absolutely. Yeah, I grew up bilingual, and actually it's kind of funny. My parents hated it when I code switched. They didn't like it. They were like, you shouldn't mix it up. You shouldn't speak Chinglish. You got to keep them separate. So, I mean, I stayed interested, but you could say this is like a way to kind of figure out whether they were right.
first person to have done that. You are our third finalist bread baker. So before you tell us what your favorite bread is, how'd you get to bread baking?
Well, to be honest, I did an undergrad in teaching, and then I moved and taught for a bit and realized I didn't like it at all. And so I came back to Boston. I'd gone to Hong Kong to do that. I came back to Boston, where I'm from, and I was like, I need a new start, but I really like baking. So I just walked into 2 bakeries, and I was like, I have no experience, but I work hard and I'm on time. And I've been working in pastry for like 10 years now. So,
right. So that means that you have a professional baking.
Yeah.
In your past.
I've been
do you
doing
still
it for a
do
while.
any of that?
Only occasionally, but I spent like a good 5 years doing it full time.
Oh, that's very cool. Okay, and what's your favorite thing then to bake?
Right now, I would say focaccia, because I had the chance to go to Italy and like learn from some real people.
Oh, like that show, Acid, Fat, Sugar, right? Like that one.
Yes,
Yeah.
yes,
okay.
totally. Yeah.
All right. Thank you very much.
Thank you.
Our next presenter is Rachel Harbeitner. She's a 5th-year PhD student in ocean sciences. She studies the bacteria of the ocean floor and how they contribute to the carbon cycle. Her talk is titled Tiny Carbon Eaters of the Deep Sea. Welcome, Rachel.
Every day, you and I are adding carbon dioxide to our atmosphere through our daily activities like driving. And this carbon dioxide has been accumulating for a really long time. And this has been one of the leading causes of climate change. Luckily, we live on this amazing planet where 3/4 of the surface of our Earth is covered in oceans. And the ocean works to regulate our global climate. One of the ways it does this is acting as a buffer for that carbon dioxide in the atmosphere. There are small organisms that live in the surface of the ocean, and they take that carbon dioxide out of the atmosphere, and they use it to build and grow their bodies. Eventually, these small organisms die, and their bodies sink out of the surface of the ocean, down through the ocean, to the deep sea, and to the seafloor. Some of those bodies are going to accumulate on the seafloor and be buried, kind of like a carbon graveyard. But some of these bodies are going to be consumed by these tiny carbon eaters, or bacteria. So bacteria live everywhere. You might be more familiar with the bacteria in your body because you are more bacteria than you are human. And they're really important for a lot of our functions, such as digestion. The bacteria in the ocean, one of their main roles is eating carbon. But we really still don't have a good idea of that full impact on how carbon is cycling through our oceans. So we went to sea, and we used this really cool giant robot to do experiments at the seafloor, where I fed carbon bodies to deep sea bacteria to figure out how quickly do these bacteria eat this carbon. So we're thinking deep sea bacteria, it's really cold, it's completely dark, and they're living under high pressure. So they're going to be really slow growers. Maybe in the course of a year, they will eat these carbon bodies. But it turns out they're eating this carbon in the course of a week. That's 50 times faster than we had expected. And when we eat this carbon, those bodies are now being converted back into carbon dioxide. So that carbon dioxide that starts in our atmosphere, gets pulled into the surface ocean, sinks through the ocean, is getting converted back to carbon dioxide, which can then circulate through the ocean, getting back to the surface and being re-released into the atmosphere. And so we know the oceans are regulating our global climate, but these tiny microorganisms that live in the ocean, even down in the deep sea, are impacting how our carbon is cycling between our atmosphere and our ocean, which impacts our understanding of that entire cycle. So we can now use this new information to better predict how our oceans are going to respond to the human impacts of climate change.
So I understand you grew up in Maryland.
I did.
In some reasonable proximity to the Atlantic Ocean.
Yes.
That have anything to do with what you decided to do with your life so far?
Yes, I've wanted to do something with the ocean pretty much my entire life.
And why the Pacific instead of the Atlantic?
Well, I spent some time in the Gulf of Mexico, worked there, went to school there, did some work on the Atlantic, and thought I'd try out the Pacific next.
It's good to diversify. How often do you get to go out into the ocean to do this deep sea research?
So for my PhD, for the past 5 years, I've been going about 3 times a year, anywhere from 5 days to about 11 days at a time.
Oh, okay. Personal question, but not as personal as you might think. Anything about your research caused you to change what you do with your life to, I don't know, minimize your carbon footprint?
It is not. I already bike a lot, but I still travel and fly, so.
I understand you tagged sharks.
I did.
In the Gulf of Mexico. Mm-hmm. What is that like?
So it was like fishing for sharks. Which
I can't say I've done.
So we set up long lines. So it's like you leave this long line out with a bunch of line hanging from it with hooks. And you hook sharks, and then you actually have to fish them in onto a ship. So my favorite was I got to tag a tiger shark, which was about 4 feet long, but it was still beautiful. It had all of its stripes still. Older or more mature tiger sharks lose all their stripes. And, yeah.
Thank you.
Thanks.
Very much. Our next presenter is Andrea David. She is a second-year PhD student in computer science and engineering. She's working on a system to detect wildfires quickly. Her talk is entitled Panther, Persistent Autonomous Monitoring for Timely Detection of Wildfires. Please welcome Andrea David.
On November 8, 2018, instead of the smell of a fresh cup of coffee, the residents of Butte County, Northern California, were woken up by the smell of smoke. The campfire became the deadliest, most destructive fire in the history of our state. It claimed the lives of 86 people, destroyed more than 9,000 homes, and devoured an area 5 times larger than the city of San Francisco. Our state is in an active battle against wildfires, but researchers across the UC system have enlisted in this fight. For example, UC San Diego gathers wildfire intelligence from a limited number of existing weather stations and uses this information along with satellite imagery to predict the wildfire's rate of spread. Another example, UC Berkeley has filled the role of our aerial support for detecting early wildfires by using their complex satellite framework, short-range drones, and expensive man-powered aircraft. My project, codenamed Panther, provides a ground support. Let's call them troops for this collaboration between the UCs. You can think of my ground troops as tens of thousands of low-cost, portable, mini weather stations collecting real-time data about the surrounding environment. These mini stations can even collect information from low-coverage areas rather than relying on expensive and sparsely located weather stations. To ensure the earliest detection of wildfires, each ground troop will come fully stocked with temperature, humidity, wind, and fuel sensors, and of course, cameras. My system is designed to work over 8 to 10 years without needing any maintenance or human intervention. In return, saving taxpayers money on expensive man-powered aircraft trips to extinguish a preventable wildfire. My troops autonomously collect precise ecological data at the epicenter of high-risk fire areas. But what if one of the troops fails? Well, my network takes advantage of modern Internet of Things technology to quickly detect failures so that we can save our fallen service nodes. My heroic Panther nodes can collect data from different areas, and they can even collect data from different areas, send it to the cloud, where we can do detailed information about weather conditions that we can analyze with artificial intelligence and machine learning tools. These tools will help fire scientists understand the long-term relationship between the changing climate and wildfire events. In partnership with CAL FIRE, I have been working on the design of my portable weather stations and plan to deploy them in the field in our neighboring SoCal demonstration forest. With my army of Panther nodes, we can finally win this fight against wildfires and protect another community from having to rebuild itself. Thank you.
Thank you. Thank you. So, what drew you to studying wildfires, and in particular, the kind of combination of computer science and engineering and wildfires?
You know, I think wildfires are very relevant. We hear them in the news all the time. We heard it for the past couple of 2 years. We heard that there's the wildfire in Northern California at the same time a wildfire in Southern California, and you could just hear them. You know, wildfires are 80% contained, 90% contained, but the question is, how come it takes them such a long time to distinguish these wildfires? And I think it's a good combination with, I like studying robotics and I like working with sensors. So I think it's a perfect application to apply something to a practical work.
How close do you think, or what would your estimate be on when something like Panther might actually be deployed?
Hopefully in 3 to 4 years by the time I finish my PhD.
Wow, that's ambitious. And then, are you hoping that this is a deployment in California first, and then other wildfire vulnerable places?
Exactly. I'm hoping to deploy them as a test in SoCal demonstration forest here neighboring by. And later I would like to have it deployed in more stations across California as well as other parts of the world.
That's great. Thank you.
Thank you.
Our 13th presenter, and I live in a world where 13 is a lucky number. Our 13th presenter is Pauline Blamont. She is a 6th-year PhD student in ecology and evolutionary biology. She studies lizards native to France and their responses to climate change. She'll tell us all about it in her talk, If Lizards Could Sing. Please welcome Pauline.
Climate change is currently affecting our planet and the organisms on it. But determining just how intensely it's doing so and whether those organisms have the necessary tools to adjust remains challenging. To help answer this question, a team of researchers, including myself, have been monitoring populations of Eurasian common lizards in France for over 20 years now. Lizards and other ectotherms, or organisms that rely on external sources to regulate their body temperature, are ideal to consult on climate change-related matters due to their sensitivity to fluctuations in their environment. These lizards are constantly having to modify their behavior, going between sun and shade, rocks and burrows. If it's too hot or too cold, it leaves them unable to feed or breed, and that has dire consequences. Part of my work aims to determine whether these lizards have what it takes to modify their behavior or acclimate in the wake of climate change and the temperature extremes we predict under it. For example, some places in France this year had seemingly endless rain with only a few days of sun during the breeding season, while others were dry and warm, refuting the common misconception that climate change only means warming temperatures. It can also mean more storms and cold spells, and thus less opportunities for these lizards to carry out the functions that they need to survive. I performed experiments with these lizards by taking them from different populations, representing a wide variety of habitats that vary in their risk of climate change-induced extinction. And I exposed them to different basking opportunities in the lab, representing long, warm days or short days with less access to heat. My results showed many of these populations were in fact able to take those environmental cues I gave them and adjust their behavior. They basked less in the long treatment and more in the short treatment, as we would expect. However, the population at high risk for extinction showed no differences between the treatments and ultimately basked less as a whole. This suggests they might have exhausted their adaptive potential. In other words, the populations that have been more buffered against these climate events still have room to adjust, but those that have been suffering longer are at the end of their rope. My findings indicate that these lizards have short-term solutions to a long-term problem, and they can only do so much. Population-level extinctions of these lizards are happening in our lifetimes, and I personally witnessed the demise of a population in my time as a PhD student. We need to work together as a global community to reduce human impacts on our climate, or both humans and our flora and fauna will continue to suffer. These lizards are the climate canary, and if they could sing, they would be sounding the alarm. But since they can't, I'm here to sound it for them. Thank you.
So how did you get into biology and lizards in France?
Well, I always loved animals, so biology was an easy one. And in undergraduate, I actually worked with fruit flies, and I decided, I'm going to level up. I was really interested. And I was really interested in lizards after taking a herpetology class, and so I applied to this lab, and here we are. And my advisor has a lot of connections to people in France, so I got to ride that plane right over there.
So is there hope for this species? As you sounded the alarm?
For this species, yes, but we have to think about a population level. There are extinctions happening, but as the name would suggest, the Eurasian common lizard is rather common across Europe and Asia. So while we might see some populations be okay for a while, ultimately, if we continue to do what we're doing, the 1.5 degree increase projected in the next decade or so, they can only do so much.
Okay.
Yeah, sorry, I don't know. I don't know what to tell you. I can't predict the future.
I don't actually need to know where to go. So let's talk about crocheting.
Yes, let's.
So you do that.
I do that. I picked it up in graduate school as like a stress relief, keep my hands busy, just kind of relaxing thing. And someone randomly asked me if I could crochet a hat for their boyfriend's cat. And I thought, why not? And I did it, and now I have an Etsy shop and I only sell hats for cats. I'm wearing my cat shirt. I really just leaned into it.
Okay, well, thank you.
Thank you.
13 presenters on stage and now off, so please join me in applauding all of our presentations tonight. We have award winners, and I will start with the People's Choice Award. Please join me in congratulating Priscilla Sung as the People's Choice Award. Oh, yeah. Not going there. I'm just doing awards, okay? Our runner-up is Rachel Harbeitner. It's a long walk from behind the camera. And our 2019 UCSC Grad Slam Award winner is Sarah Keenley. Congratulations to all of you. And I'd like all the finalists to come up on stage, please, so we can have a big group photograph. Okay, so we're going to try to do this as a photograph. So, I don't know. We'll see. We all got... Come on down.